Okay. So now I'm going to use it for another variable. It means from 2 to 100, I'm going to check. So here x value, we can keep like this, no problem. X value, here initially I told you for a single number. Means if I take 5, if I take 10, if I take 20 or 57 like that, if I take single number, that will check whether it is prime or not. Here, instead of taking a single value, I'm going to treat it, I'm going to put it in a loop. For example, x I'm starting with 2. So whether 2 is prime or not. So till where I'm checking x lesser than or equals to 100. Till 100, I'm going to check whether there are any prime numbers or not. X plus plus. So previously I have taken a single value in x. Now I'm treating x as an iterative variable. Always this x will be changed. So for this x, whether this x is prime or not, like that it will check. If it is a prime number, means there will not be any flags. So here will come out, if the flag value is 0, simply we'll print that as a prime number. Here observe here, I'll show you the logic. If it is 0, simply I'll print the x value, therefore percentile d, some space, prime numbers I'm printing, comma, here I'm taking that x I'm printing. So I'm closing another. So here inner loop I have closed. The inner loop that will check whether there are any flags or not, means factors or not. If there are any factors, so here the flag value will become 1. Whenever the flag value will become 1, that will come out and check whether it is prime or not. Means it will become 1 means that won't be printed. Whenever the flag value is 0, then only it will be printed. So always we have to keep for every number, the flag value initially is equal to 0. Here we need to remove this. Okay, here I am assigning. Now I'm going to check what are the prime numbers I'm having from 1 to or 2 to 100. So it has become read-only file. We need to do it forcefully. GCC space prime 2.c. I'm checking. See, we can check the prime numbers from 1 to 100. See, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, all are the prime numbers. So if you want to do it for means different numbers, you can do. If you want to do it for different ranges, for example, the prime numbers in between some 50 to 60 or 70 to 80. So not only 100, more than 100, means in thousands also, for example, some in between 2000 and 2500, what are the prime numbers we are having? We can keep the range here. Some x is equal to 2000, x lesser than or equal to 2500. In that range, what are the prime numbers we are having? But whenever a number becomes bigger, for example, if it goes to thousands and if it goes to lakhs, then that will take the time. Here number of calculations will take place, number of iterations will take place. So then the time complexity and the time complexity will be increased. So for example, if I take some 2,50,000 437 I'm having, whether it is prime or not. So that time, how can I say? From 2 to that 2,50,437 annanu. Then before that 436, up to 436, it has to find is there any factors or not. In worst case, there may be factor in last and biggest numbers. So that time we need to do all these iterations 2 lakhs times. We have to repeat the loops. Yeah. So for bigger numbers, this code is not feasible. It is not the right coding. So I'm giving you a small task. How can we reduce the time complexity to find whether a particular biggest number in lakhs, that particular number is prime or not, with a low time complexity. So we are having different logics for that. So you have to go through that, then I will teach you. Okay, this is about a prime number. So as I have given in the previous class, some Armstrong number, the logic for Armstrong number, then palindrome, reverse of a number, then finding number of digits in a number. So everything is same logic we'll use, mostly similar.